Is it pecan or pecan?
Android.
Okay, so we're starting chapter 6, and this will lead us up to Christmas. The tentative plan is for us to have a quiz on Friday, then we'll finish up the chapter next week and probably test Monday or Tuesday of the following week. Another thing that you need to be thinking towards is your notebook check, okay? And so what that is I pick out 20 different notes, okay? Every hour is different. And I'll put them up on the board and I'll say, okay, I want 1 1, 1 3, 1 5, 2 1, 2 2, 2 3, 3 1, 3 4, 3 8, whatever, okay? And I get 20 of them. And I collect them. You put them in numerical order, you staple them together, and then I collect them and look to see that you have them and if they're filled out. So if you're absent, you can't just have a blank one in there. You won't get credit for it, okay? And so I go through, and they're worth 5 points apiece. It's a 100-point grade. All right? So that's something that you need to be looking towards if you have not done that. Get your notebook organized so that it goes really quickly, and that you can pull those out. If you don't have them filled out, if you're a little lazy when we do notes, or if you've been absent, then you need to go either watch the videos or get it from a friend and copy theirs from them. All right? So that's going to be coming up here pretty soon. This chapter primarily deals with quadrilaterals. We've been doing lots of stuff with triangles, so we're going to take a break from that and work with some quadrilaterals. Except today's lesson deals basically with polygons. Okay, remember polygons are your triangles, your pentagon, your hexagon, so all right, so a diagonal. A diagonal is a segment that connects any two non-consecutive vertices of a polygon. Non-consecutive means not in a row. So your triangle doesn't have any non-consecutive vertices because there's just 3 of them. But your quadrilateral does, and you go from this vertex to another one. It can't be one that's next to it. It has to be like that. It's got one. Your pentagon has several, 2 from every vertex. But that's what the diagonal is. Okay, it connects any 2 non-consecutive, 2 that are not in a row. Now, our primary thing that we're working with today is how to find the sum of the interior and the exterior angles of the polygons. Now, we know in a triangle, the sum of the interior angles of a triangle is what?
180.
180. We learned that earlier in the year, okay? A triangle has 3 sides. There is one triangle, and we know that the sum of the interior angles is 180. Okay? Now, we want to talk about how you can find the sum of the interior angles of your quadrilateral, your pentagon, your hexagon, your 18gon, whatever. So I'm going to show you how we come up with this formula, because there's a formula you can use, and I'm going to show you how we come up with it. If you will draw all the diagonals you can from one vertex, so from this vertex, I can draw one diagonal. That creates 2 triangles, okay? And each triangle, the sum of the interior angles is 180. So these 3 added together is 180, and these 3 added together is 180, okay? That means that is 360 degrees. So a quadrilateral has 4 sides. I have 2 triangles, and it's 360 degrees. Your pentagon has 5 sides. And so if I draw all my diagonals from one vertex, I can draw 2 diagonals. That gives me 3 triangles. Each one of them is 180 degrees. And so that's 3 triangles. And if I take 3 times 180, that's 540 degrees altogether. Your hexagon has 6 sides. And I can draw 1, 2, 3 diagonals, which creates 4 triangles. Okay, each of them 180. And so that's 720 degrees. So hopefully you see kind of a pattern for me here. Because what if there were insides? Okay? If there were insides, how many triangles would there be? N minus 2. You notice that there's always 2 less triangles than there are sides. So it would be n minus 2. And in each case here, I took the number of triangles times 180, so that would do the exact same thing. 180 times n minus 2. And so that is the formula that we use to find sided polygon. And this leads us to our theorem called the polygon interior angle sum theorem. And it says if a convex polygon has inside and S is the sum of the measures of its interior angles, then S equals 180 times x minus 2. So S is the sum of the interior angles, N is the number of sides. And so we can follow this formula. Okay, let's say that there were 25 sides. What would we do? Say that again. 180 times N minus 2, and N is 25, so it'd be 180 times 23, right? Because there's 25 sides, so it's 180 minus 23 times 23. Okay, good. All right. So here's one. We'll do it together. This is a little bit smaller numbers. Find the sum of the measures of the interior angles of an octagon. Okay, and again, my formula is 180 equals 180 times N minus 2. How many sides does an octagon have? 8. Okay, so 180 times 8 minus 2 is 180 times 6. And so I end up with 1,080 degrees. Okay, so that's the sum of all the interior angles added together of an octagon. Okay, now let's look at something a little different. It says find the measures of each interior angle of a regular hexagon. This time I want each interior angle, and it's a regular hexagon. So I want each individual one, and it's regular. What does it mean to be regular? Do you remember? I have a regular polygon, regular hexagon. What does it mean to be regular? All sides are equal, and what else? And the angles are equal. Okay? So all sides and angles are congruent. Okay? All sides and angles are congruent. Okay, so I want each interior angle, and it's a regular hexagon. How many sides does a hexagon have? 6. Okay? Alright. So, what I have to do is, first of all, I gotta find the sum of all the interior angles. Okay, to be in a hexagon, it's going to be 180 times what? Not 6, because 4, because it's 6 minus 2, right? You have to subtract 2. So 180 times 4, which we already did this a while ago, we said it was 720. Okay, so the sum of all of them is 720. I want each individual one, and there's 6 of them, and it's regular, so what do you think we should do? Okay, we're going to divide it by 6, which is going to give me 120, and that is my interior angle. Okay? So that gives us a little formula. If you take S, which is the sum of the interior angles, and you divide it by the number of sides, that gives you the interior angle. That's only in a regular polygon. Okay, and not all the polygons are regular, like this next one is not. It says find the measure of each interior angle. Okay, and they're different. Okay. In order to do that, though, I need to find the sum of all of them together. So I would do what? This is a quadrilateral, so what would I do to find that? 180 times 2, right? So 180 times 2, because there's 4 sides, 4 minus 2 is 2. So that's 360. And you know what? It used to be to your advantage to know that quadrilateral is 360. Because we add up all the angles. Okay, now I'm not going to divide this by 4 because not all the angles are equal. What am I going to have to do to find x? Okay, add all the angles together and set it equal to 360. So I've got x plus 2x plus 2x plus x equals 360. So that's 6x equals 360. I divide both sides by 6, and x is 60 degrees. But it's asking me to find each interior angle, right? So what A and B are x, right? So that takes care of 2 of them, and they're equal to each other. So the measure of angle A equals the measure of angle D, and they are both 60. Okay, but what about B and C? They're both 2x. They're equal, right? What are they going to be, though? Huh? regular, you just have to divide by the number of sides, and one where it was not, and that's when you have to add all the angles together and set it equal to the sum. Any questions before I go on to the next thing? Okay, now, the polygon exterior angle sum theorem. Put a little star by this one, it's important. Okay, put a little star by it because it is important. This one says that first of all, let's talk about the exterior angle. Let's talk about what an exterior angle is. Remember, an exterior angle is created by an extension of one side of the polygon. And so then that angle right there that's created with that extension and the side of the polygon is your exterior angle. Okay? It says if the polygon is convex, then the sum of the measures of the exterior angles, one at each vertex, is 360 degrees. So what that's saying is if you were to extend every side and you were to add each one of the exterior angles together, one at each vertex, it's going to equal 360 degrees. And it doesn't matter how many sides there are, it just has to be convex. Okay? So in this case, if I did the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5, that's going to be equal to 360. What if there were 48 sides? What would be the sum of the exterior angles of a 48 line? What would be the sum of the exterior angles of a 48 line? 360, right? No matter what, no matter how many sides. Now, if you're talking interior, it depends on the number of sides. But exterior is always 360. Okay, always. Alright, so, using the same picture here, it says find x in the pentagon above. It says that it gives you values for 1, 2, 3, 4, and 5. So what are we going to have to do to find x? What? Add them up together and set it equal to 360. Very good. So I'm going to do 6x minus 5 plus 5x plus 2x plus 3x plus 10 plus 2x minus 5, and that's going to be equal to 360. So I'm going to add all my x's together. 6x plus 5x is 11x, 13x, 16x, 18x. And then if I add my constants, I've got negative 5, 10, and negative 5. What happens? They cancel, right? And so I've got 18x equals 360. And I'm going to divide both sides by 18. And so x is going to be 20. I think that's all that they're asking us to find. Alright. So let's look at the next one. It says find the measure of each exterior angle of a regular nonagon. So I want each exterior angle, and it's a regular nonagon. What does it need to be regular? All sides and angles are equal. A nonagon has how many sides? 9. Okay, it wants each exterior angle. What do you think we should do? 360 divided by 9, because the sum of all the exterior angles is 360. And so if we divide it by 9, that's going to give us what? 40 degrees? So there's a little formula for us. If I want to find an exterior angle, I'm going to take 360 and divide it by the number of sides. Okay? And that's in a regular polygon. Now, before we go on to the next one, tell me what relationship does an exterior angle have with an interior angle? They're a linear pair. What does it mean to be a linear pair? They equal 180. So let's put ourselves a little note. Your interior angle and your exterior angle are a linear pair, which means they're supplementary. Add up to equal 180. So with that in mind, our next example says that the measure of the interior angle of a regular polygon is 108. find the number of sides in the polygon. Okay, now there's two different ways this one can be done. I'm going to show you the shorter way. If you look in your book, they do it the long way. That's not my favorite way to do it. If I know, all I know is the interior angle, right? And I'm trying to find the number of sides. What can I find knowing the interior angle? Yes. Okay, I can find the exterior angle, which would be 180 minus 108. That's going to be 72 degrees. Okay, good. All right. So knowing it's regular, right? Each one of the exterior angles is 72, right? So now what can I do to find out number of sides? Okay, very good. If I take 360 and I divide it by 72, then that's going to give me 5, right? Which is the number of sides. So there's another little formula for me. The number of sides would be 360 divided by the exterior angle if it's a regular polygon. So that one kind of works in two different ways. If I want to know the number of sides, I could do, if I want to know the number of sides, I could do 360 divided by the exterior angle. Or, if I want to know the exterior angle, I could do 360 divided by the number of sides. Okay, both of those are regular polygons. Okay, last one. Find the measures of an exterior angle and an interior angle of a convex regular octagon. A convex regular octagon. What should I find first? I can really do either. I have one preference over another, but we can do either. What should we find first? We want an interior and an exterior because I have an octagon.
The sum of the interior angles.
Okay, you want to start out with the sum of the interior? So that would be 180 times 6, because 8 minus 2 is 6. That's 1,080. Okay? But I want the interior and the exterior. So what would I do with that?
You would divide that by 8.
Okay, divide that by 8, and that's going to give me 135. So my interior angle is 135. How do I find my exterior angle then? 180 minus 135, which is 45. Okay, that's one way to do it. That's not my favorite way, but it definitely works. But I find the exterior angle first. It's regular. Can I find the exterior angle first? What would I do? Divide 360 by 8, which is going to be 45. Okay, and so if the exterior is 45, then what do I do to find the interior? 180 minus 45, which is 135. Both ways work, right? Either way? Okay. To me, this seems like less work, but either way. Whatever way you remember that's correct is the best way to do it, right? Okay. How many sides does a dodecagon have?
12.
How do we remember that? You do remember a decagon, right? Yes. Oh, you remember a dozen? So dozens? Okay. That's a good way. What I remember is that a decagon has 10, right? Most people can remember that. And dodecagon has 2 more letters than decagon. So if a decagon's 10, a dodecagon has 2 more sides than a decagon. That's how I remember. But either way works, right? Okay, now real quickly, let's just go back over this. We learned what a diagonal was. We used that to determine how many triangles there were in each one of these polygons. And we came up with this theorem to find the sum of the interior angles. Remember, it's 180 times n minus 2. It's always 2 less than the number of sides. Okay, so if it was a 15-gon, we do 180 times 13, right? Then we talked about how if it's a regular, in this case a hexagon, if it's regular, we find out the sum and we divide by the number of sides, and that tells us each individual interior angle. If it's not regular, we still have to find the sum, but then we have to add up all the angles to equal that sum. Then we learned about The exterior angles. What's the sum of the exterior angles of a 35 line? 360. No matter how many sides there are, um, all the exterior angles added together is 360. And then we did a couple of examples with that. This one, it gave us values for each one of the angles, so we had to add it up and set it equal to 360. If it's regular, we can take 360 divided by the number of sides, that gives us the exterior angle, and vice versa. If we take 360 divided by the exterior angle, it gives us the number of sides. And we also talked about the fact that your interior and your exterior angle are linear pair. Any questions? Okay, your assignment's on the board. I did omit number 42, so you don't have to do that one.